Let's continue with Module 1 with Part 3. So we were talking a moment ago about SQL Server and the platform that MEDITECH uses for all data repository instances, and how data repository is different. Really, why does it matter if it's on a separate system? Well, it matters because we have a relational database storage system versus MEDITECH's proprietary storage system. It's much simpler for us to get at the data using off-the-shelf tools from Microsoft, from Crystal Reports, products like Cognos or Tableau, even Microsoft Excel. We can write queries or at least view SQL Server database tables. And because Microsoft SQL Server uses the Transact SQL or T-SQL programming language, now we can also write efficient store procedures to query and report back that data to our reporting applications. So we've got off-the-shelf tools, we've got an efficient storage system in SQL Server, which at the end of the day makes it much easier for us to write reports because we can use standard software. It's very efficient and very fast, well-performing when you write SQL store procedures against a relational database. And lastly, the data is never archived from the DR. Unlike MEDITECH, which does have purge or archive parameters for some applications, all the application data, once it's in data repository, stays there. It never gets archived or removed. So we have a purpose-built reporting platform. That's what makes DR different. So if you're not familiar with relational databases, let's talk a little bit about how we use them. The first mission, really, of any relational system is to store and manage data while maintaining its integrity. And by integrity, we mean both physical and logical. Physically, what that means is preventing data corruption in the actual data structures, which is uncommon but can happen. Logically, integrity means preventing, say, duplicate data and ensuring that the relationships between records are intact and make sense. In other words, if I have a record with a patient and I have a record with the patient's lab test, how do I make sure those two things are associated correctly to each other? SQL data, SQL Server data, or any relational database data is stored a little bit differently. No, it's not a black box, or in this case, it's not a black cylinder, but any relational database is comprised of a collection of what are called tables, which really are the foundation for how data are organized, both structurally and conceptually. Another name for a table is actually relation. So we think of tables as being related to each other in some way, which is where we get the term relational or relational database. Tables are further subdivided or organized, their data, into both columns and rows. So let's take a look at a simple example, an Excel spreadsheet. Here's one that I put together to track my home energy usage, both heating oil, automotive bills, and electric bills. I really wanted to keep track of these things because we bought an electric car and replaced our heating oil furnace with electric heaters, and I was hoping to prove, and I did by the way, that I was spending less overall after making all those changes than before. So a spreadsheet, if you look at how it's organized, is organized into columns and rows, just like a database table. Tables are sometimes also called entities. That's how we decide what goes into a table. Determining what data for what entity goes into a table is really a database architect issue. In the case of MEDITECH and Data Repository, all those decisions have been made ahead of time. You don't have to design the database from scratch. In other words, we're just inheriting an existing database that's already designed the way it should be. So we organize our entity or our table data by columns and rows, as well as also storing some metadata or properties about the data that gets stored within that table as well. Columns are the vertical representation of data within a table. Now, columns are also sometimes known more generically as attributes, as in they describe some single property or attribute about whatever the table's entity is. So let's say if we have a table of patients, one attribute or property about a patient is the street address. So we might have a single column called address that has that information contained in it. Columns also have other properties or metadata that describe the information contained in that column. So for example, it might be the length. How many characters physically can we accommodate? What is the data type? That is to say, is it an alphanumeric characters can be stored in here? Is it numeric only? Columns can also participate in indexes, which we will talk about a little bit later in this course. Lastly, we have rows, or the horizontal representation of the data. So if you think of a row, sometimes called a record, as the combination of all the attributes, that is to say columns, for a single entity within that table or a unique record. So it's really just a listing of related facts about an entity. Now rows themselves are also subject to indexes in the sense that we have something called the primary key, which determines what makes a row unique within a table. And we'll talk more about primary keys in a little bit as well. So here's an example of a table, an actual table from a data repository database. You can see I've written a simple SQL query across the top. Select top 1000 star or asterisk from a testDB table name, himrec main. Divided into columns and rows. So the entire table is contained here in the green box. Let's just call it 20 rows. And then I have a single column, in this case visit ID I've highlighted in blue, just to represent the vertical representation of that table and that particular column. And then we have a single record or a row, on row 10 in this case highlighted in yellow, which is the combination of all the attributes or properties for a patient whose name is Ruby C-Test. Well, look who's here, it's Sally. Sally pops up now and again to give us quick tips and syntax advice as we look more at our T-SQL code and other areas. You may have noticed on the previous screen we used a keyword top in the query I wrote, followed by the number 1000. So what do we use the top keyword for if you're not familiar with that? Well, it's a handy way when writing ad hoc SQL queries to limit the results to the first number of rows or records that you specify. This is a great way to simply preview or sort of browse through table data without retrieving every single row from a table, which in the case of very large tables can be a performance hit on the server and on your local network. So we use the top keyword again to limit results as we're browsing data typically. That's the end of part 3. We'll pick up again in part 4.